Hey folks, it's David from Streaming Relativity, home of the Astro DNA Observatory. Okay, so anyone who owns an SCT is familiar with the downsides of the design, specifically the focusing mechanism, which actually moves the primary mirror to achieve focus. And whenever we move that primary mirror, we run the risk of several problems, all of which really can disturb imaging as well as observing. But thankfully, we can implement alternative focusing mechanisms that mitigate at least a couple of these issues, making it easier for us to image and, of course, to observe. And the solution that I am implementing is in this box. It's the Baader Planetarium Diamond Steeltrack Crayford Focuser. And in this video, I'll cover why SCT owners might consider implementing this type of fine focusing mechanism. I'll go through the process of how to install this particular model on my C11, including the use of the Baader 2-inch click lock system, as well as adaptations to the standard ZWO electronic autofocuser. There's a couple minor mods that you need to do, but with those minor mods, you can use the standard kit to drive this focuser. And I've not seen a lot of content out there on the web related to this solution, so hopefully I'm filling a gap for folks. And if you like this kind of content, go ahead and subscribe. I produce content generally every week, and we have a great community here, and I would love your support. All right, with that, let's get focused on SCT focusing. So I covered the SCT telescope design in an earlier video, and I'm going to leave a link to that in the description for those who are interested. But I want to quickly review the SCT focusing mechanism because it's going to help you better understand the challenges and why there's room for an alternative method for fine focusing. Now, the SCT achieves focus by moving the primary mirror along a greased baffle. Here's the mirror, here's the baffle. And this movement is controlled by a focusing knob that's usually at the 3 o'clock position in the back of your SCT, at the back of the SCT. That knob is actually connected to a threaded rod. And the knob itself is fixed in place, and it's supported by 2 bearings that allow it to turn smoothly. But because it's fixed, as you turn the knob, the threaded rod is either going to push or pull on the primary mirror housing, and that's going to slide the mirror along the baffle. Now, turning the knob clockwise essentially pulls that mirror away from the secondary mirror, and the secondary mirror being located in the corrector plate of an SCT. And that increases the telescope's effective focal length. Now, if you turn it counterclockwise, pushes the primary mirror closer to the secondary mirror and effectively decreases the focal length. So in a traditional SCT setup, the focal plane's location is fixed by your image train. So wherever your eyepiece is or your camera sensor is, the distance from the back of the SCT, that is the location of the focal plane. So to achieve focus with the SCT, you have to adjust the focal length by moving the mirror so that it converges with the physical location of the plane. Now, this is very different from other telescope designs, like a refractor, for example, where there's a fixed non-moving objective lens with a specific F ratio, focal ratio, therefore a specific location of the focal plane, and it is the job of the focuser to move the image train to align with that focal plane. So with that, you understand the basics of SCT focusing. Now let's talk about what some of the problems are, starting with image shift. Image shift is a result of that mirror as it's sliding along the baffle, kind of changing its orientation ever so slightly relative to the secondary mirror, and that's going to move your target along in your eyepiece or on your sensor ever so slightly, sometimes even dramatically. But it's more than just that. What we wind up having is problems with collimation. You have any shift in that mirror, and your collimation can be way off. Finally, it could be very difficult if you're manually focusing to keep things steady, especially when you're doing planetary or you're doing lunar, or you're dealing with some really bad seeing. Every time you just touch or breathe on that knob, you're going to get a lot of shaking activity, and that could be very frustrating. To solve these problems, we're going to introduce a Crayford-style focuser at the rear cell of the SCT, and we're going to minimize the need to move the mirror.
Okay, here we have it, the fully assembled Diamond Steeltrack Crayford focuser with a planetary imaging train, which I'm using with the C11. This is tested, and I'm going to cover the components in this train and how I set it up, and hopefully this will be helpful for you guys. So the first thing is that everything I'm going to talk about applies whether you're doing planetary or you're doing DSO. It doesn't make a difference what camera you're going to use. Completely, this applies to any type of imaging that you intend to do with your C11. So the components for this particular train, what I've created here, include, of course, the Crayford focuser, and you can use any focuser you want. I'm going to cover the Baader Planetarium focuser. It seems to be the one that's most available, and it's actually quite good, and we'll cover its features. I'm also using an adapter, which is the Baader click lock adapter. And this is a matter of preference. You don't need to use this click lock adapter. You can use the standard 2-inch clamshell compression ring that comes with the focuser without any problem, and we'll talk more about that. Then I also have it's a T2 to 2-inch adapter that is a Baader product as well, that allows me to screw in a filter that I can use with this planetary camera, an IR UV cut filter. And then I have an extension ring of about 21 millimeters, which is to enable me to get close to the published 151 millimeter backspacing that supposedly is optimal for the C11 XLT without a reducer. Okay, so this is the image train itself, and I think for those who are interested, I'm using the 678 MC camera for my planetary work. It's a 2-micron pixel camera, and it allows me to get an image scale of about 0.14 arc seconds per pixel, and which is ideal for planetary. So, okay, let's start with the focuser itself, and hopefully this is clear. I'll probably share some pictures. The focuser, it's a Crayford focuser, so essentially there's a housing, which is the bulk of the focuser itself, and this thing weighs about, let's call it 2 pounds. And the focuser also has a focusing block attached to that mount, and the focusing block is that kind of square, or I should say rectangular block of metal that sits on top of the outer housing. Now that block is spring-loaded, and it basically enables pressure to be put down on the draw tube. The draw tube is what allows for the extension and retraction of the focuser, so effectively shifting the focal plane. And you can increase the pressure on that plate by using a center hex screw. There's a hex screw dead center of that focuser block, and from the factory this is rated at about 6 kilograms, which is more than enough to handle the weight, and that's the kind of hanging weight that the threads themselves, that the focuser itself can handle before it starts to slip. 6 kilograms, that's pretty heavy duty, and certainly my modest image train here for planetary doesn't even approach that, nor would my DSO rig for that matter. However, if you do have a heavier payload that you want to control, hole with your focuser, you can tighten that center screw. If you tighten that center screw, it will also tighten the focusing mechanisms itself. So Baader doesn't say you can't do it, they say you can do it, but they also, this thing is published for 6 kilograms. So I think that, keeping it with the factory tension is probably best. I will point out that the block also has 4 hex screws on the outside. They're the larger hex screws that allow you to remove this block and reverse it. So if for whatever reason you need to reverse the block and put the fine focusing on the other side, you can do that by simply removing those 4 screws, rotating it 180 degrees and setting them back. I found no reason to do that. Even with the, a lot of times when you put a Crayford focuser on the back of an SCT, you're worried about the autofocuser interfering with the manual focus knob. The offset of this housing allows me to easily position this with its standard focuser position and even screw the entire assembly on and off without interfering with that the manual focus knob of the SCT, which is located around 3 o'clock on the back of those housings. So, okay, now, final thing I'll point out about the focusing block is that there are 3 additional, let's call them set screws. They're black. There's 2 to the right and left of center, and 1 to the right of center. I should say 2 top and bottom of center, and 1 to the right of center. As I'm looking at it, it's probably reversed for you. Those are non-functional, and that's explained in great detail in the manual that comes with the focuser. But those are for mounting accessories, which I have taken advantage of one of those holes to mount the ZWO focuser. You will need to take advantage of at least one of those holes. So the standard tip screwdriver is all you need to remove that set screw, and I thought I had one over here. I do, just so you see what they are. They're actually like a hard plastic, and you remove that, and they're M6 threads. So, okay. There's also on the focuser block, there's something called a brake, which is an M6 thumb screw. However, this M6 screw has a hollow interior because when it is screwed in place, it goes over a plastic pin. And as you put pressure on the brake, it will again affect how freely the fine focus and coarse focus knobs spin. It will never shut it off altogether, and it is really not necessary. And there's even if you have this fully tightened, you can still use an autofocuser with it. I happen to be using it as part of the mounting hardware for this ZWO electronic autofocuser, and you will need to do the same. Do not lose this brake. We're going to talk about a mod that I have to make to this bracket in order to use the ZWO EAF natively. We'll get to that in just a moment. Finally, there are adjustment screws, set screws, very tiny screws on the extreme right and extreme left of the focuser block, both on top and to the front, on the front of the plate. Those are used to adjust the tilt of the image axes of the focuser. I felt they come perfectly aligned, so perfectly straight from the factory. If you have a particular implementation that requires you to do this, you can adjust right, left, top, bottom using those screws, and the procedure for that is explained in the manual. I see no reason to have to do that. In terms of those who are not going to be using electronic autofocuser, this is a 10-to-1 ratio. So for 1 full turn of the coarse focuser, you're going to have 10 turns of the fine focuser. Very smooth. I would say mechanically it feels close to 0 backlash. That does not mean that the autofocus system has zero backlash, because now you're talking about the backlash of the system, and there's always backlash with these motors. But manually, this was a pleasure to focus with. All right, now on every focuser has a side that faces the telescope and then a side that faces the image train. And with the Baader, you have a couple of options for both ends of the tube. And this is the box that it came in. By the way, for those that are interested in, I got this from First Light Optics, and I had never dealt with them before, but they were wonderful. They shipped the product quickly to me. It was well packed, came from overseas. I'm really excited about it, how quickly I was able to get this. Now, I'm just going to show you that when it ships, there are two adapter plates that it ships with that are attached to the focuser. Let's start with the telescope-facing side. So on the telescope-facing side, you'll notice that this is a step down. It's basically a step down from 3.28 threads or 3 1/4 threads down to 2-inch threads. So this makes this focuser functional for smaller SCTs. I believe for the 9 1/4 and lower SCTs, you can simply screw this adapter into the back, and this is how it comes shipped. Screw that into the back of your Baader focuser, and then that gives you 2-inch threads that you can then screw into your smaller SCT. Natively, this screws perfectly onto the C11, so that's one adapter that comes with it. Another adapter that is now on the other side, the image train side. And this adapter is that clamshell, that 2-inch clamshell adapter. And I have to tell you, I'm really impressed with the quality of this simple part. These set screws are beefy. The clamping mechanism is precise, very tight. This is normally this is how it ships. So normally this would come. I have a Baader click lock on here, but it comes inserted, and so this nose gets inserted all the way into the draw tube. And I hope you can see this. I'll take some pictures. There's a little groove, a little channel right up against the front face of this. And that channel, when you insert this into the draw tube, that channel aligns up with six very tiny set screws that go all the way around the draw tube, the end of the draw tube. And that allows you, when you seat this in place, you tighten down those set screws, and that's how you attach this. It comes attached from the factory. Now, I generally don't like these clamshell connectors. I like threaded, but if I'm going to do something that's compression fit, I really like the Baader click lock product. So what I did is I removed this with those 6 set screws, and I took the Baader click lock adapter, which is designed for this telescope, inserted it and tightened down the set screws. So that is where this click lock comes from, and that's how this click lock is attached to the focuser. So now I can screw directly into the back of the C11. I can use my Baader click lock to attach a 2-inch accessory. And so how do you go to 2 inches? Well, it's actually really simple. There's another Baader product, and you don't have to buy Baader products for this. This is standard with, you can buy standard inexpensive products. Baader's a little bit more of a premium, and you're paying for a little higher quality engineering, in my opinion. But really, you can use inexpensive products that you can buy on Amazon for this. But a T2 to 2-inch adapter is what I have attached ultimately to my camera. I have a spacer in between, but that's optional. But what's nice about this Baader T2 to 2-inch adapter is that you can screw in filters. And in my case, I screwed in an IR/UV filter. And that sits just on the front side of that T2 adapter. And then I have a spacer, 21 millimeters, which screws directly into my camera. And I believe these are the camera's, I think the camera's M42 or F42, either way it's 42 threads. And that gives me my assembled train. Now, let's talk about adapting the ZWO electronic autofocuser to the focusing block. This is, Baader sells their own focuser, and it's belt driven. And you see here we have a belt, we have the pulley that's built into the fine focuser. I dislike pulley-based systems for anything. There's always a lot of backlash, and I've never used their product, and I'm sure it's very good because judging from the quality of all the other products that I buy from Baader, I'm sure it's an excellent product. But I like direct drive right onto the shaft of the focuser, and the standard electronic autofocuser, that the most present one sold by ZWO, works great. It has a coupler that fits the shaft size of the Baader, so you don't have to kind of worry about the coupler fitting. And the only challenge that you're going to have is that you're going to mount this using one of the 3 accessory holes that I talked about. That's an M6 screw, plus you're going to use the brake, and you're going to use the center groove on this ZWO bracket, and it will just make it. It'll be actually perfect in terms of lining up with the coupler, the focus shaft coupler. It's absolutely perfect. Now, the problem is that this center groove is too narrow to accept the thickness of the M6 screws that the Baader uses for attaching accessories and the brake. So it's a really simple solution. I used a Sharpie. I basically lined it up. I knew that where my brake was going to be, and I just marked, and it turned out to be right at the end of the channel, that center channel. I marked where I needed to bore out that groove a bit, and I also marked where the brake bolt goes. And with a 15/64 bit and a cordless drill with a clamp, clamp this thing down to your workbench, very quickly, very easily created a widened hole in this aluminum plate. With that allowed the M6 threads to freely move through, and I was able to tighten this thing down snug. And I'll tell you that overall, other than there's some backlash in the motor itself, this thing works beautifully. For those who are interested, I'll show a screenshot of my electronic autofocuser settings. I tried both absolute and overshoot methods, and I've opted for overshoot method in Nina. All right, with that, this is ready to be screwed on to the back of the SCT in the observatory. Okay, so the installation is really straightforward. As I mentioned, natively this is going to screw right onto the rear of the C11 cell. Here's the manual focus knob. Okay, very nice. Now, I also like to do minor adjustments to the new Baader focuser actually does have a quick release to allow for rotation. Older models do not have this, so I take advantage of it by making sure that my unit is square. I actually don't need to do anything here. Tighten down that thumb screw, and we're in good shape. Now you can reconnect your accessories. Okay, I'm going to talk briefly about the procedures here for focusing, because it is important. However you set your train up, and let's assume that you rack your focuser to about the halfway point. This is a 30 millimeter focuser travel. So rack it to 15 if you'd like, or 10, something in that neighborhood. That that is going to dictate where the initial image plane is located. You're going to rough focus your SCT manually using the manual knob so that everything comes into focus on that plane. Now, the final focusing rotation of this knob should be in the counterclockwise direction. We do that because that is pushing up on the mirror as opposed to pulling away from the mirror. By pushing up on the mirror, you're kind of pushing the mirror uphill is the expression that we use. It keeps tension on that rod, and it keeps tension on the mirror, so any kind of wiggle due to the loose fit around the baffle will be kind of in its permanent kind of state. So it will no longer wiggle. Once you've done that, you can then rely on the Crayford focuser for the finely focusing the instrument, and that's the benefit of this system.
Okay, it's time for the software setup. So the ZWO EAF has a range of about 60,000 steps. The 30 millimeter travel of the Baader requires 10,000 of those steps. So I use Nina for my sessions, and here's my configuration, which you can find underneath the autofocuser option screen. Now I'm using a step size of 50 and an offset of 4. So when you run the routine, the autofocus routine, it will test focus starting at 200 steps out to 200 steps in from your current position. And it's going to test focus every 50 steps and determine the best focus position based on the curve fitting algorithm that you have specified here. So I'm using hyperbolic, which seems to work very well. You can experiment with other parabolic and trend lines, etc., but I like to keep things simple, and hyperbolic seems to be doing well for me. Now, backlash settings are important, and it's up to you to test what the proper backlash settings will be for your system. The backlash of the focuser itself is really near 0. But the ZWO motor and that flexible coupler, they have backlash. And if you really do a good job of aligning your motor and the shaft and the coupler has not a lot of bend to it, you should wind up with a backlash that's equal in either direction, meaning in or out. And I measured this at around 75 steps. And because the backlash is equal either way, you can use the overshoot method, which is a great approach for autofocusing. And I set the backlash to twice the value of the measured backlash. So I set it to about 150. Now, that's double the measured backlash. And so the way that this works is every time that you focus in the out direction, because I've specified the backlash on the out position, the focuser will overshoot your target by 150 steps, and then it automatically reverses in the in direction by that same 150. Now, assuming that you have equal backlash in both directions, they cancel out and you'll wind up in the target position that you're looking for. And it works very well for me, but don't assume my values are the right values for your system. You need to do some trial and error on this. I have to say I'm pleased with the results, and as we wrap this video up, here's a little scene of me using SharpCap to do my second capture of Saturn with this rig, and already we can see that the results are greatly improved. Yes, part of it was seeing. The seeing was better this evening, but so was the focusing experience. I still have more to do to calibrate the scope, including fine collimation, but I'm very, very pleased with this fine focuser implementation. Okay, folks, let's call that a wrap on the video. I hope you learned something about focusing with SCTs and some of the alternatives that you have available to you. Give it a try. I think you'll minimally be less frustrated and hopefully have better results in your imaging as well as observing. I do have a couple of videos coming out. One more on the SCT setup. It'll deal with collimation, which is an important topic. That's my next video that I have slated, but then I'm going to shift back to refractors. I miss my refractors. I absolutely love refractors. Not that I dislike SCTs, but I'm a refractor guy. So I'll be doing a setup for traveling with the SVX90T. So look forward to that video as well. And if you're not subscribed, go ahead, subscribe. It means a lot to me, and it'll keep you notified when these videos come out. So with that, I will see everyone on the next video.